Hi friends, welcome to What I Have Learned. I am so glad that you are here with me today. And today I'm going to come to you and talk with you about word problems, specifically the separate word problem type. A couple weeks ago we did the join word problem type, and I can link to that in the description after I'm done. And today I wanted to show you some word problems with examples of the separate word problem type. And what I'm going to do is go through some examples and show you some models and different strategies that I use with my students to solve these different types of word problems. And today we're specifically looking at word problems that separate. So there's 4 different types of word problems. There's join, separate, part, whole, and then compare word problems. So we've already taken a look at the join ones, and we're going to take a look at separate today, and then we will take a look at the other 2 in the coming weeks. So let's go ahead and get started. I have a copy of the word problem on the screen. We're going to start with a separate result unknown. So for this particular problem, I have my students start with blank spaces. And I'll link to that blog post as well and explain to you why I have them start with blank spaces. Basically, it takes away the numbers from the word problem. So often my students would look at the numbers, add them together, and be done. And they didn't actually read the word problem and look at the problem for what the problem was saying, trying to comprehend the problem. They would just try and get through the math as quickly as possible, and oftentimes weren't correct in adding the numbers together. So what I've done is taken away the numbers in the word problem to have students figure out how to solve the word problem before I actually give them the numbers. The other reason why I remove the numbers is because it's very easy to differentiate the word problems when you remove the numbers. I can give some students single-digit numbers and other students double-digit numbers, and it just makes it very easy to differentiate for different types of students or different levels of students. All the way kindergarten through 3rd grade, really. I've used these more in a 1st grade and 2nd grade classroom, but those are the different reasons why I give word problems without numbers. As I mentioned in the other video, there are 3 main words that my students learn when we are working on word problems. The first word is start. And in both join and separate problems, the word start is a key part of the problems. There's a start, a change, and a result. Okay. And those are the 3 main words that we take a look at as we are reading the word problem. This particular separate word problem is a separate result unknown, and that's just for you as a teacher to know what the problem type is. I have it down at the bottom of the word problem in very small type so that you can see what it is, but I don't necessarily tell that to students. What I ask for students to find is what the unknown is in the problem. So I ask them to find the start, the change, and the result in the problem, and then I ask them what we are solving for. What is the unknown? So for this particular problem, it starts out, Ralph had blank carrots. He ate blank carrots. How many carrots does he have now? And so I actually, on an overhead or whiteboard or smartboard, we used iPad, so I didn't really have a smartboard, we would label the word problem. So there's an S for start, a C for change, and an R for result. So in this problem, Ralph had blank carrots. That's your start. He ate blank carrots. That's the change. That's how many he ate. And we also talk about the verb. When you eat something, it goes away. It's no longer on your plate in front of you. So if we can pretend Ralph is a bunny, has however many carrots on his plate in front of him, and he eats some, they're no longer on his plate. They have gone away. So it's a separate word problem, which makes it a subtraction problem. How many carrots does he have now? And that now part is the result. Okay, so we're going to start with, the problem gets set up with the start minus the change equals the result. Okay. And in this particular in this particular problem, we are solving for the result right there. And so we will insert numbers for the start and the change, and this is the easiest type of subtraction problem students solve. Often it's taught in kindergarten and 1st grade, and in 2nd grade it becomes more of a review for them. But I always start start students with easier problems as we are learning this type of problem solving. Alrighty, as I explained in the last video and earlier in this video, you can easily differentiate the numbers. If I wanted to start with something like 10 and then he ate 5 carrots, or maybe I want to start with, let's say he's a very hungry rabbit, and he had 35 carrots and maybe he ate 15. So you can easily differentiate the numbers and be able to show students different ways to solve the problem. I'll go a little bit higher for the second graders. So we'll say he had 35 carrots and he ate 15 carrots. So the problem is set up like this. And 35 take away 15 that he ate has how many carrots are left on his plate. There's no plate in the problem, but we can pretend. As I mentioned in some of the other videos, I often have students solve problems using a number line. I'm going to make this. See, is that going to do it? Let's see. There we go. Make that a little bit smaller so that you can see it. So in this particular one, we start at 35, and let's say he ate 15, so I might separate that into 10 and 5. So making a jump of 10 down to 25 and making a jump of 5 down to 20. And so there's my 15, and so he has 20 carrots left on his plate. So that's one way to solve the problem. You can also figure out, this one is easier with this problem where you're subtracting the 10 and then the 5 because he ate 15 carrots. I'll show you another number line with another one of the problem types, which shows you jumping a little bit differently. But because this one, he actually ate 15, you actually are taking away 15. And so doing the jumps down the number line this way works well. So this is a separate result unknown problem. Let me erase this really quickly and show you one of the other problem types. And we will take a look at a start or a separate change unknown. And so this word problem type is a little bit more difficult. Let's see. There we go. Is this the one I have? Nope. That's the next one. Let's see. There we go. Yep. So this is the problem. I'm going to make it a little bit bigger for you. Maybe. Let's see. There we go. So this is the problem that we're going to take a look at, and it's a separate change unknown. And again, that's information for you as a teacher, not necessarily something I would tell students. But what I do ask them is which one of these are we looking for? So they don't need to know the technical term of the problem type, but they do need to know what part of the problem is unknown. What part of the problem are they solving for? So here's the problem. There were blank fish in the big tank. The pet shop owner moved some of them. Now there are only blank fish in the fish tank, in the big tank. How many did the shop owner move? So again, moving, let's see, moved. There's your verb in the sentence. When you move something, you're going to move a portion of them or separate a portion of them. So with littler kids, kindergartners, first graders, if they need it, we act out the problems and we figure out what the movement is within the problem. What's the verb in the problem? So there's, a group of kids huddled together in a fish tank, and then the pet shop owner moves some of them, so you can see that they are being separated from the group. And so that becomes the basis for the problem type. Join problems are going to be addition problems, and separate problems are subtraction problems. And so it gives you the operation and the problem type within it. So in this one, it's separate. Up here, there were blank fish in the fish tank. There's your start. The pet shop owner moved some of them. There's the change. And we don't know what the change is yet. Now there are only blank fish in the tank. There's your result. We know what the result was and we know what the start was, but we are solving for that change. So my word problem then becomes, I usually don't put in this many blank spaces because we'll have numbers at this point, but your word problem becomes a start plus a change or minus a change equals result, and we are solving for that change. And likewise, you can use different types of numbers, different levels of numbers for different kids. Let's say they are guppies and there are 48 of them, because Guppies are small, and you can stick multiple in a fish tank. So you have 48 fish in the fish tank. The pet shop owner moves some of them, and now there are 29. I could cross a 10 there. So now there are 29 fish in that fish tank. How many did he move? Well, your problem becomes 48 take away something equals 29. And here is where a subtraction problem can look a little bit different with the number line. Because we know what the start is and we know what the result is, we are now trying to figure out what the change is, which can be the jumps. In the last video, one of the key things that I mentioned was that word problems lend themselves really well to matching the model that you use. So in this particular instance, we're using a number line, but how we use the number line is dependent on how the word problem is set up. So we are searching or trying to find out the change in the problem, which is how many fish he moved. And so in that case, we're going to figure out how many jumps there are between those two numbers. Likewise, like I mentioned before, we like to use friendly numbers. So we're going to go from 48 to 40, which is going to be a minus 10. And then 40 down to 30. Sorry, I got a step ahead of myself. That's a minus 8 and a minus 10 over here, and then a minus 1. And so students will be able to add that 8 and 1 together to get a 9. And so we've got 19 fish that he moved. And of course, I mentioned in that previous video, I have my students write it out in a sentence, oftentimes a paragraph as we move on in the year. So they would explain how they solved the problem and how they used the model to solve the problem. Alrighty, so I'm going to show you one more problem. And this one is the most difficult of the separate problems because it has the start that is unknown. And so in this particular problem, we don't know the number that the problem starts with. Alrighty, so here is this one. Nope, that was the first one. Start, there we go. We don't know, make it a little bit bigger. And I didn't really pay attention to the last problem and whether or not the number line got messed up. So I can show that again at another time if it did. But in this particular problem, we don't know the start of it. So it's a separate start unknown problem. And again, I wouldn't mention that to students, but I would present the problem to them. And we would label the start, the change, and the result. So here's the start. Ashley had some crackers. There's the start. She gave, and again, we talk about gave. And the gave, you give something away, you are subtracting from your amount that you have. She gave blank away to Timothy. Now she has blank crackers. How many crackers did she have to start with? Now, giving something away isn't always a separate problem. So you've got to figure out and have students figure out the verb and what is actually happening with that verb. So here's an example. Ashley had some crackers. Timothy gave her blank more crackers. How many crackers does she have now? So in that case, that problem is a join problem because someone else is giving Ashley crackers. In this problem, it's a separate problem because Ashley, the subject, is giving someone else her crackers. And so you have to have students analyze the problem and what's going on in the problem to figure out the operation, whether it's subtraction or addition in terms of a join or separate problem. In this instance, we looked at the verb and the fact that Ashley gave some away, and so it's a separate problem. It's not always black and white, and the word give or gave can be used in both type of problems. So you've got to help students pay attention to the context of the problem and what's happening in the problem. And again, it's going to be a separate minus change equals result. This equation is going to be used throughout all of the separate problems. It's always going to be separate or start, take away, change equals result for separate problems. And it's the same thing for join problems. Start plus change equals result. Okay. It's set up with the same structure for both of those problem types. And when we get into compare and part whole, it changes a little bit. but it's always going to have that structure. So again, I'm going to use a little bit higher numbers. Let's see, Ashley had some crackers. She gave away, let's say 25 to Timothy. Now she has 12 crackers. How many crackers did she have to start with? So my problem becomes my unknown, because I don't know how many she had to start with, minus 25 equals 12. And this is one of those times where I'm like, do those numbers work? But they do. So here's my number line. And this problem is going to be a little bit different. Let me see. Make sure that you can see it, because I know I covered up the other one. There you go. This problem is going to be a little bit different because we have the result. We know where she ended and we know how much she gave away. We don't know where she started. And so in order to use a number line in this instance and make it match the problem and help us solve the problem, we're going to start here with 12. And we're going to use a strategy that's called count up, or increasing it. I often use count up with my students, but we will often relabel things, relabel different strategies based on what the students want to call it. So I'm starting at 12. I'm going to count up 25 and get to a number. And so we're going to see what we get to. Now, 25 can be broken apart into 20 and 5. And so that's going to help me solve the problem a little bit. This 12 right here, I can count up 2 10s. So we're going to say plus 10, and that'll get me to 32. It'll get me to 32 right there. And then I'm going to count up that 5, and we're going to say plus 5, and that gets me to 37. And so Ashley had 37, was it crackers to begin with, and then she gave away the 25, and so here's her 5, 10, 10, which is her entire 25 that she gave away. And then Timothy had, or now she had 12 crackers after she gave 25 away. And so you can see that this model was built a little bit differently than the other two. I didn't start with my start because that's what I had to figure out. So because my start was unknown, I started with the result down here and counted up by the change, how much she gave away, and to figure out how many she started with. So those are the three different problem types for separate word problems. There is a separate result unknown, which is often the easiest one to use with students, and it is most commonly taught in kindergarten, first grade, often review for second grade. There's a separate change unknown, which is the second easiest, and taught in first grade, second grade, and there is a separate start unknown, which is going to be the most difficult for students, but if you help them figure it out using specific models like number lines and helping them with the different problem types and using similar language, we now have 6 different problem types between the 3 join and the 3 separate word problems in which students can use the same type of language of start, change, and result. So all of those word problems can use the same vocabulary, and so you're able to build off of what students already know within their word problems to be able to solidify their understanding and create a routine for problem solving in your classroom. It's really great for students to be able to have a foundation and expectation and know how to solve the word problems, and giving them those skills, the vocabulary, the routine to fit it in is really, really helpful. So the routine that I use with students is that we obviously read the problem, but what we do is we label it. We label the start, change, and result. And then we will set up our equation with the problem and figure out what is unknown. I'll give students the numbers and they can set up their equation with numbers, and then we choose a model and solve it using that model. Most often with students we will use a number line to solve it, but we could also use base 10 blocks. So let me show you this particular problem using base 10 blocks. And it's very similar to using a number line. I would again start with the result because it is a known. And so with base 10 blocks, you can draw it out and sorry, that's 12. Again, getting a little bit ahead of myself, 25, and then figuring out how to put those two together in order to figure out what he started with, which would have been, or she started with, which would have been 37. So using base 10 blocks is another model. Number lines are one of my favorite for second grade with smaller kids. Base 10 blocks, you could actually count them out with smaller numbers if you have like Unifix cubes or connecting cubes. So just whatever works with students. So anyway, thank you for joining me here for this and letting me show you and share with you some of the strategies that I use with students in the classroom. And feel free to leave a question down below and I will definitely get to it and answer it. And within the description up above, I will leave links to different blog posts, including the join video that I did a couple weeks ago, and look for a part whole video coming up in the next couple weeks, and I'll show you 3 different problem types for part whole, and one of them that's pretty open-ended and kind of fun to do with kids every once in a while too. So take care, have a good Sunday afternoon or evening or wherever you're at in the world, and I will talk to you later. Bye-bye.